In exercise number 54, we are asked to evaluate a particular trigonometric limit. We have the limit as x approaches 0 of the sine of 3x times the sine of 5x divided by x squared. Now, as usual with the limits, if it is feasible to do so, you should try out direct substitution and see what that would give you. If we try plugging in 0 for x, we have zeros here. Sine of 0 is 0, so we have 0 in the numerator and 0 in the denominator. So we have 0 over 0. That is indeterminate, which means that the limit may exist, but we're not able to evaluate it directly. We'll need to do something a little bit more indirect. And that will require some sort of manipulation here. Now, useful limits to consider here are the couple of trigonometric limits identified in this section. If you haven't worked with those and memorized them yet, you should pull those out. I recommend maybe pause the video, find them in the section. It would actually be a good idea to copy them down into some notes or a reference sheet so that you have them on hand. There are two limits, one that involves sine and one that involves cosine. And when you have a problem like this, you'll probably want to do some algebraic and or trigonometric manipulations to try to get parts of the problem to more closely resemble those limits so that you can maybe see what you should be doing. Well, we don't have any cosines here, we just have sines. So that suggests that we should maybe try to make these look a little bit more like the sine limits. Now we have two sine functions here, so let's split this up into a product of two fractions, sine 3x and sine 5x in the numerators. And we have this x squared. We have an x here and an x there, so let's divvy up the x squared to be, put one of those factors with each fraction here. So we have sine 3x over x times sine 5x over x. That looks useful, right? Now, we have a limit of the form sine theta over theta, and the key there is that theta would need to mean the same thing in numerator and denominator, right? We have sine of 3x, we only have x down here. We need a 3x. And there are a few different ways that we can introduce that. One is simply by multiplying by 3 over 3 as kind of a fancy 1, right? And we can multiply the second part by 5 over 5. So we haven't really changed anything there. We've just done a little bit of scaling of the fractions. And now let me kind of rearrange a little bit. The constant 3 and the constant 5 are sort of in the way. Let me pull those out. That, of course, is 15. I'll write that in the next step, but just to make it clearer what's going on so it doesn't look like there's some sort of magic happening. Let's do this. So by pulling out the 3 and 5, we can write this as sine 3x over 3x. And I'll also go ahead and split this apart and write this as a separate limit. I'm using the product rule for limits, product law, I guess, the limit law for products. Let's put it that way. So we have a limit of a product, and I will write that as a product of limits. This is somewhat conditional. It only works if these limits turn out to exist, right? So this is sort of contingent on what the results turn out to be. We'll have to wait and see what happens. 3 times 5 is 15. Let's go ahead and simplify that. So now we have this limit here and that limit there. Now, if you are comfortable with the appropriate packaging mentally, you can go ahead and evaluate those. But if not, you might find it useful to do a little bit of change of variables here. Perhaps we let t equal 3x. Then we would have the sine of t divided by t. And as x approaches 0, 3x approaches 0. So that means that t approaches 0. So we have the limit as t approaches 0 of sine t over t times the limit, and similarly, let's pick a different variable just to avoid confusion. Let's use u. If we let u equal 5x, we would have the sine of u divided by u, and again, as x approaches 0, 5x approaches 0, so that means that u is approaching 0. The limit as t approaches 0 of sine t over t is 1. That is the special trigonometric limit that was introduced in this section. And the limit as u approaches 0 of sine u over u is 1. Same thing, right? So what we find here is that this limit evaluates to 15. The limit as x approaches 0 of sine 3x times sine 5x over x squared works out to 15. So this, together with the examples in the textbook, they all kind of involve some slightly different algebraic tricks, but this should give you some idea of some of the strategies that we tend to use when evaluating trigonometric limits. You'll need to practice plenty of these, of course, get used to the different ways we play around with algebraic and trigonometric expressions and manipulate these to get them into forms that we can actually evaluate.